This may sound weird, but I love beets. They're reddish-purple on the outside and the inside without using disgusting red 40 or other food dyes. And they taste great. So, I recently went to the supermarket to buy some beets like I normally do. But, much to my horror, when I arrived at the shelf where my beloved beets were normally stored, there were no beets! Instead of the delicious pile of beets, there was a sign that said, "This product has been removed due to levels of detected cadmium higher than the maximum permissible concentration of 0.006 milligrams per liter. Cadmium is a heavy metal that can be transferred to crops through irrigation water." So I went home with no beets, but an urge to Google the effects of cadmium poisoning. Cadmium poisoning affects the respiratory and cardiovascular systems. It harms your kidneys and gives you, skeletal lesions. Ugh. Ittai disease or ouch disease. Ouch! Also, a study published in 2015 showed that overexposure to cadmium can cause damage to the olfactory cortex, meaning you can't smell. This scared me, and it still does. And I thought, there should be some way to fix this cadmium poison problem, right? I mean, the less ouch disease, the better. So I thought for a long time, water cleaning. Nope. Something that could eat cadmium. Nope. A super anti-cadmium zapper. Nope. Each idea had some sort of minor problem. Well, maybe I wouldn't describe the problem with that last one minor. Anyway, I was very stuck and frustrated. That was until my gaze fell upon a cup of yogurt on my desk. It said, "Bacteria are our friends." And then I thought, that's right, they are. Not all bacteria are bad. They help us out all the time. I like to think of those as bacteria on a quest. So, what if bacteria came on a quest to help us with this cadmium problem? What if they could tell us if irrigation water is contaminated with cadmium? And since I'm an artsy person, wouldn't it be cool if the bacteria could change color when introduced to a media, for instance, irrigation water, that contained cadmium? Turns out that they logically can. Let's take a closer look. Here's a diagram of a prokaryotic cell, which are what all bacteria are. Bacteria are very simple. They have a cell membrane, and some have pili on the outside, so that some bacteria can share genetic material. The main genetic material is kept here in the center of the bacteria. And then there's the ribosomes, which use the genetic material to produce proteins. Now, we're going to want to modify the genetic material so that the bacteria will produce proteins that will help us achieve the effect that we want. Let's zoom in on a protein. Here is a receptor, which can be thought of as a lock. It will only work if the right key or ligand is put into it. A ligand is a signaling molecule used in cell signaling. Once the lock is opened, some sort of reaction or response will be triggered. In our case, we have our normal receptor with the ligand. But here's a cadmium ion. Now, the receptor is more attracted to the cadmium than the ligand. Cadmium takes the ligand's place. This replacement triggers a reaction different from usual. In our case, we'd like this reaction to be the emission of some pigment. When we zoom out, the whole bacteria is the color of this pigment. But we must realize that this color change would not happen immediately. Since the replacement takes place at such a small level, it would probably take a couple of minutes for a group of bacteria to emit color visible to the naked eye. Now, a couple of minutes might seem like a long time, but it really isn't. Today, if we'd like to test for cadmium in a sample of water, we'd have to go to the source of the water, collect the sample, go back to the lab, and test it. That sounds like a lot of work. And who likes a lot of work? With this new color-changing bacteria, we do a lot less work. We just have to go to the source of the water, collect a sample, and then put the bacteria into the sample and do the testing right there. That's a lot less work. We love a lot less work. So altogether, the idea of color-changing bacteria is very probable and could eventually become fact. With them, we could easily detect cadmium in irrigation water. This would lead to less cadmium poisoning, less ouch-ouch disease, and more beets. Yum!